quantities which can be measured are called physical quantities. Anything which can be measured is a physical quantity. For example, we can measure length of the object. Length can be measured in meters, centimeters, kilometers. Magnitude is the numerical value. Okay, but here we are talking about quantities like length, speed, time. We can measure time, we can measure speed, we can measure length, we can measure weight, we can measure force, we can measure pressure, density, right? So all these quantities are physical quantities. Anything which can be measured is called physical quantity. Okay. So for example, length, mass, time, temperature, you can read from the screen, right? So there are two types. We have two types of physical quantity. One is scalar quantity and second is vector quantity. You can make your notes. Okay, scalar quantity and vector quantity. So scalar quantities are those which have only magnitude and they do not have direction, which are described by their magnitude only, by the numerical value only. Okay, for example, if we say that speed of an object is 40 kilometers per hour, then speed is a scalar quantity. Distance covered by an object is 1 kilometer. Distance is a scalar quantity. Okay, on the other hand, vector quantities are those physical quantities that are fully described by both the magnitude and direction. If we say that a car is moving with a speed of 40 kilometers per hour towards east direction, then here we have mentioned the direction in which the car is moving. Not only the magnitude, not only we are talking about the magnitude of the car, which is 40 kilometers per hour, at the same time, we are also considering the direction of the car in which it is moving. So both the magnitude and direction we have considered here. So it is a vector quantity. Okay. So when we say that car is moving with a speed of 40 kilometers per hour, then we don't know in which direction it is moving, where is it is going, right? In that case, we consider the speed of the car as a scalar quantity. But if we add the direction to it, then it becomes a vector quantity. Okay. So vectors are those physical quantities which have both the magnitude as well as direction. For example, examples of scalar quantities you can see we have mass, length, time, distance, speed, temperature. So these are the examples of scalar quantity. On the other hand, if we talk about vector quantities, so we have all new terms which we are unfamiliar with. You have never read about displacement. You have never heard the term velocity, acceleration, force, etc. Force you might have heard in class 8 when you have done chapter force and pressure. But acceleration, we know acceleration is in the word accelerator, we are quite familiar with it, is in the car. We press the accelerator and speed of the car increases. This is what we know, right? But other quantities, we say, if we say displacement, velocity, then we have never heard about these quantities. This is the first time we are talking about these quantities, right? So see, velocity is nothing but speed with direction. Velocity is nothing but speed with direction. As we have taken the example, if the car is moving with a speed of 40 kilometers per hour towards east direction, then we have added the direction, east direction, to the velocity speed of the car. Speed is 40 kilometers per hour, and we have also mentioned the direction in which the car is moving, then it becomes the velocity of the car. Okay. Should I move to the next slide? Yes. Now look at this. So we have a situation where an object is moving from position A to position B. Because this is the starting point of the object. The object has started its journey from point A, right? Because the object has started its journey from point A. So A is called the starting point and the initial point. We call A as initial point. And it reaches B after some time. So B is the ending point. It is the destination, or we can say it is the final position of the object. Okay. So this object can choose any path of its choice. This object can go through the dotted path or the solid path. Okay. Suppose the actual path traversed by the object is the dotted path. Okay. So object is moving like this in this direction. Look at the arrow, the cursor. So object is choosing this path. Object is opting this path and going to point B. Actual path is the real path. Actual में वो कैसे गया? See, this is the distance because This dotted line is the distance covered by the object. So object has started from A, okay? Then it follows this path, dotted line path, and reaches point B. And this is the actual path covered by the object. So distance is the actual path covered by the object. On the other hand, displacement is the shortest path between the initial and the final position. Okay, displacement is the straight line distance or straight line path between the initial and final position. So we simply join the points, initial and final point, to get the displacement. The word displacement, it comprises of two terms. You can see displacement, displace plus ment. Displace hona. Displace means out of place. The word displace means out of place. Okay, so displacement. So what is the difference between distance and displacement? Yes, it is the actual path covered by an object, and displacement is the shortest distance between the initial and the final position. So let's consider a situation. Suppose this is your home, this is your college, and this is McDonald's. And you have started your journey. You're riding bicycle. You're going from home to college, and then you go to McDonald's. And what is the total distance covered by you? First, you have covered the distance between home and college, and then you have covered the distance between college and McDonald's. So total distance covered by you is home to college is HC and college to McD is CM. So DHC plus DCM. Okay, this is how we measure the distance. We can find the net distance like this. Okay, and what is the displacement? See, what is your initial position in this particular case? You have started your journey from home. So home is the initial position and you ended at McDonald's. Okay, so McDonald's is your final position. Displacement, though uh, you have not come from this home to McD, this covered this distance. You have not covered that distance actually, but your displacement is the distance between home and McDonald's only. Okay, आप गए तो ऐसे हो, you have gone from home to college and then from college to McD. But if we talk about displacement, displacement means out of place. कितना अपनी position से कितना displace हुए हो आप. So you were at your home, now you are at McD, so you are at a distance of DHM, we'll say, and that's your displacement. It is the shortest distance between your initial and final position. Okay. So distance and displacement. So when distance and displacement are said to be equal? When the object is covering, yes. When the object moves in a straight line, yes, it is not taking any turn, it is just going straight, right? Then we say that distance and displacement are equal. Suppose this is the initial position is home, final position is McDonald's. Then in this particular case, distance and displacement, they are same. Okay, so distance is DHM and displacement is also DHM. When the object moves in a straight line, then its shortest distance is the distance. Is actually the distance, actual distance. Shortest distance is the actual distance. Shortest distance is the displacement. Okay, so displacement and distance are equal. Clear? And displacement is not equal, is never equal to 0. Okay. But distance is never equal to 0, but displacement can be 0. Distance is never equal to 0, but displacement can be 0. So we'll consider a situation that if you are at home, you go to McD and you come back. Then what is the total distance covered by you? Distance is home to McDonald's and then McDonald's to home. And displacement is because your initial and final position are coinciding. Okay, so in this particular case, your initial position is your final position. So you have not been displaced at all. You are at your position only, right? जहां से आपने शुरू किया था वहीं पे पहुंच गए हो ना, तो आप डिस्प्लेस तो हुए ही नहीं हो अपनी पोजीशन से. So displacement is 0 and distance is the home to McD and back to home. Okay. So magnitude of displacement may or may not be equal to distance traveled by an object. See, distance is always greater or equal than displacement. When is distance and displacement equal? When the object travels in a straight line, then distance and displacement, they are equal to each other. Okay. In other cases, distance is always greater than displacement. This is the only case where we have both equal, and in rest all the cases we have distance always greater than displacement. Okay. So now we can differentiate distance and displacement. So distance is the length of the actual path traversed by an object. On the other hand, displacement is the shortest distance between the initial and final position. Okay. Distance is a scalar quantity and displacement is a vector quantity. Distance is a scalar quantity and displacement is a vector quantity. Unit of distance, how do we measure distance? In which unit? Meter. Meter is the SI unit. And see, displacement is also shortest distance. So its unit is the same. Okay. Both distance and displacement, their SI unit is meter. Okay. What are the differences? Distance is the actual path covered by an object. Displacement is the shortest distance between initial and final position. Second point, distance is a scalar quantity. Displacement is a vector quantity. SI unit of both meter. Okay, distance can never be zero. Displacement may or may not be zero. Okay, displacement is zero when initial and final position coincide with each other. Now let's take a question. So a person moves from A to B and then goes to C. So the motion, the complete motion of the object is A to B to C. Okay. So we have to find distance and displacement. How will you find? We have done this question earlier. You know how to do it? So first write total distance covered by the object. Total distance covered is the actual path traversed by an object. Actual path is first he moves from A to B first and then AB and then he goes to C. AB and BC. So this is the actual path. है ना? He started his journey from A, goes to B and then turns back and reaches point C. So this is the actual path covered by an object. AB plus BC. Okay, so we have the values here. AB is 400 meter and BC is 150 meter. So what is the total distance? 550. You have written? Good. Displacement भी निकाल लिया? Good. And total displacement, and we can write displacement now. Displacement of the person. Displacement is the distance between initial and final position. So initial position is A. This is the initial position and this is the final position. So displacement is AC. How can we find AC? We simply have to subtract BC from AB, right? BC from AB. So what will you get? 400 meter minus 150 meter, and the answer is, give me the answer. It's 250 meter. Done. Verify your answers. Next question. So complete motion of the object. He first started from A to B, and then he goes to C. Yes. AB is 12 meter and BC is 5 meter. AB is given, AB is 12 meter and BC is 5 meter. Okay. So we have to find, this is the complete motion of the object and we have to find distance and displacement. Let's find distance first. Distance is the actual path traversed by an object. So he started from A, goes to B and then goes to C, right? So AB plus BC, 12 meter plus 5 meter. Answer is 17 meter. This is what you are getting. And how will you find displacement? What is the initial position?
A.
And final position is?
C.
So displacement will be AC.
A.
Yes, this is the initial position of the object, of the person, and this is the final position, right? So displacement is AC. How will you find this AC? By Pythagoras theorem, this is a right angle triangle. Okay, so hypotenuse square is equal to perpendicular square plus base. Put the values here. We have 12 square plus 5 square. What is 12 square? Very good. 144 plus 5 5 is 25. And this is 169. Square root of 169 is 13.